I just want to get started by saying that my first robotics experience was seeing an R2-D2 robot at school. Someone came in and did a presentation, and it was a life-size R2-D2 driving around, not crashing into any kids, not crashing into any of the obstacles in the way. It had some sensors that were able to detect how far away it was from something, stop and then turn away and move. And since then I've been interested in all things to do with control, automation, and that side of things. So today what I wanted to do was to take a look at a bit of where we're starting in schools, where we're starting with I guess anyone who's enthusiastic, who wants to get started, who doesn't know where to get started, what they can do, things they can try and learn, things they can get their hands on, projects that they can work on, and then see how that relates to things that exist in the world at the moment, and then also where we have some of our future technologies and innovations coming up and how that can lead into those areas. So just to get started, one particular piece of technology that a lot of people might have seen is something called Arduino or Arduino, mainly based as a control system. It's got a lot of inputs and outputs that you can use to, I guess, sense the real world environment, do some controls, program, have a bit of fun with it. I know that we've got another presenter coming up, David Inglis, who's going to go through a few examples about things that you can do which may be very intriguing and also a lot of fun and insightful and give you a bit of a creative platform to work on there. So I won't go too much into this one. But a lot of people are using these ones for projects, for smaller robots, for temperature control, for smart home systems, I even know some people that are using them on their snowboards to check the G-forces that they're getting when they're going down slopes. So there's a wide variety of uses for them. The cost isn't too prohibitive, so a lot of people can get right in. There's a lot of online resources and a lot of forums and online communities that are happy to talk about these things as well, so there's a lot available there. A lot of hobbyists tend to use things like this, and you can plug in a lot of other sensors, expansion boards, have some very interesting projects set up, and you can even set them up with multiple ones to sense and have some intercommunication going there. David's going to cover that a bit later in another talk, so I won't go too much into that one. Another one that seems to be fairly popular is the Lego Mindstorms. Currently they have what's called the EV3, which is the third version or the third iteration of their control system. Usually things like Lego Education and other groups that sell these as part of some robotic starter kits tend to provide a lot of other sensors like touch sensors, colour sensors, things that you can use to interact with your environment, and then also have motors and wheels and other things that you can use to either drive around or use it to move other things. So there's one thing where I've seen that a group of people have written a Rubik's Cube solver where they've got a lot of motors which turn the Rubik's Cube in a lot of different ways. And they use a camera to then work out which colours are on which side, and then they can do the rotations, and the fastest I've seen solved I think is about 3 or 4 seconds, so fairly fast. The price is a bit more for that one, but you're getting a lot of extra things in there as well, and a lot of the sensors which you don't get with the base starter kits in things like the Arduino circuit boards. There's a lot of different companies that are out there that are doing varying levels of hobbyist or even a commercial level automation and robotics based products. So some of those I'll just touch on. So Intel have one. They also do a lot of work with Arduino based components as well, and they have things that can plug into that. And then also National Instruments builds larger industrial sized components that are fairly rugged and can be used in a lot of robotics and control and automation systems as well. So there's a wide variety of starting platforms depending on how much that you want to spend, how many people that you want to work on it, whether you want to do smaller projects or large-scale projects, like even with industrial-sized automation or even autonomous cars, autonomous vehicles, that sort of thing. Something that I haven't touched on here, but I'll touch on a little bit later towards the end, is to do with drones and swarm technology, if you want me to go into that a bit more, but I'll leave that as an optional extra. Okay, so sensing the environment. There's a lot of ways that we as people can perceive the world, and there's a lot that we understand naturally. But when we try and think about how a computer or a robot is going to process that information, it starts to get very complicated very quickly. So just going through things like sound, you can have different pitches and frequencies, so you can start to get different notes. You can have the loudness of it, and you can also, if you have multiple microphones or multiple sensors, you can get the direction as well, so you can start to hone in on particular voices or particular signals, which can come in handy if you're going to use that for sonic interference as well, so you can see if you're getting closer to a particular object, then the time delay from when you send the sound to when it comes back actually becomes shorter. You've got a couple of, there's three others that I want to touch on here. Light and some, let's say, lighting, if you want to go towards a particular light source, or if you want to navigate around certain objects, then you can see how reflective the surface is and either go towards it or stay away from it, or use it as some sort of guide, as a rangefinder to know where you are in a room or some other environment. Colour is an interesting one. If you want to identify things of a certain colour, pick them up, or to try and do some changes with them. So I was talking before about the Rubik's Cube. They'd have the cameras, and then they can also have just individual colour sensors if they want. Something I'll come on to a bit later is how you could possibly use the colour sensors in the Lego controllers, not only for like a line follow, but you can also start to control the speed with different colours of lines as well, and that is something that's used in industry in another way, but I'll get to that a bit later. One other thing that comes in handy is for pressure or force or touch. So simple switches where you can push a button and it knows that it's pushing up against something. That can be a last port of defense to stop a motor from driving any further in case you push something over, or if you are gripping something, then you want to stop gripping. A lot of the prosthesis that people use for robotic arms, they actually have sensors on the fingers that make sure that you don't crush a piece of glass once you're holding it in your hand, because it can sense how much pressure that you're holding it, that you're putting into that glass. So just a bit of an example here. If you were to have your own robot or your own Arduino circuit that had the sensors connected into it, you could, for instance, follow a path or a line by going on the boundary of between the white and the black areas to follow that line through and to get to a particular object. And say if you wanted to sense what that object was, then you could do a lot of different things, including laser range finding, or you could use sonic sensors or even lasers just to work out how close you are to that object, if that's all you want to do. And you can even use colour sensors or other means to see if that's the object that you want to identify and pick up, or if you want to then try and find another one after that. So in this particular example here, you could think, okay, so I've gone along a path, I've identified an object, that's not the one I'm looking for, so we can try and find another path and then go along that one and identify that particular object. So that's something that we can now start to think, we need some logic and we need some control behind this. And so that's where the programming languages start to come in. So with the Arduino-based products, usually it's programmed in something like a C language or a Java type language. I've seen a few projects that are using processing these days, which is an introductory Java-like language, but it's actually fairly powerful as well. The Lego versions use mostly something which is like a graphical programming language, so you can have a block which is a sort of turn, a go forward, sense something, loop, and then you can build up logical structures in that way as well. So there's different versions of programming languages depending on which form that you want to introduce your students or peers to. So we touched a bit on the sensing the environment and then a possible workflow that you may want to do for a simple type decision. So do a line follow, and then inside that there's some methods that you would use to go over a line to try and follow the edge of the line, or follow two edges if you've got multiple sensors. Use some sort of color sensor or some other type of sonic sensor or some sort of distance measurement to see if this is a particular object that you want or if it's the one that you want to go to, and then you can make decisions in your programs to then say, no, actually I want to go and do something else. So this is where a lot of the programmatic thinking can then be injected into a curriculum or have it as a bit more of an interactive way of trying to make those decisions. And it's fairly approachable as well. So those are some interesting ways that you can see locally how robots can make decisions and how you can start to program those ones. What I'd like to do now is ramp it up a little bit and go into some examples that we've got at home that we might have, say, in warehouses, ferries, or in shipping ports or anything else like that. And you can see the stuff that we've talked about already is directly relevant and happening there in other places around the world already. So it's the same logic, but there's a little bit more happening under the hood. So I've tried to give image credits where I can, and all of these are open images, so I haven't gone through any copyright violations or anything like that. But if you do notice anything, please do let me know. So this particular person took a time-lapse photo of their Roomba going around their room. And what they noticed is that there did not seem to be any logic to it whatsoever. So on the left, this is an automatic vacuum cleaner that has a charging docking station where it's plugged into a power point, and then it can roam around a room, not knowing how it looks, and just use sensors to try and find places that it needs to clean. There are randomized algorithms that it can run, so it knows after a certain amount of time it needs to make a random turn and then keep on going. So if you do that over time, then you notice that you actually get pretty good coverage of the entire room. And there are a lot of algorithms out there tested and tried to see which ones were the best in different circumstances. If you pay for larger models, then you can actually get ones that can sense an entire room or use external sensors to map the room for you, and then it can optimize its path and do it a lot faster if you want to. There's a little nodule on the front there, which I don't know if you can see very well on this slide, but that's another light sensor itself. So you can have these things which might be something that size that you can put down in a room, and it creates a beam across the room so that if the robot comes up to it, senses it, it knows to stop and move back because it's a virtual wall. So you can think about in your programming or code logic that if you get up to that point, keep on moving until you have that sensor triggered, and then you can turn around and move away. There have been some times where if the robot's moving too fast, then it's actually gone across that line and then it tries to go back and it can't, so then it just keeps on going and then falls down the stairs or something like that. So you need to think about how fast the robot's going so that it can sense that line without actually crossing it. So that's one level of automation. We can upscale this even further. So we have these types of vehicles called automated guided vehicles. And these can either be completely autonomous as in they think for themselves and do everything themselves, or they can communicate with some central server to think about, okay, give me a task, I need something to do, what do you want me to do? And then it can go off and do its own thing. So you see this in a lot of logistics and warehouse situations where you'd want to have efficient packing, storage, but also minimise any human error or traffic or driving issues that might crop up as well. So just with these two vehicles here, neither of them are remote controlled, so there's no one on the other end that has any joysticks that's driving them around and can look in a camera. These are completely driving on their own. They have a task, so they know they need to take a package, grab it, and put it over either in a storage area or into a provisioning area because this needs to be shipped out. And so there's power management, so when it notices it's getting low on power, it's got to go and recharge itself. There's obstacle avoidance, so if there's things on the ground, even though a warehouse is usually pretty flat, there are other things that might have fallen off a pallet or even other robots that have fallen over or other robots that are moving as well. So they need to avoid each other. So on the back of this red one, you'll notice a little yellow device on there. That's a laser type system that it can use to detect any obstacles in front of it or behind it. I'm not sure which way is considered front there. And so these machines are being built specifically for different purposes. But we can go further than this. There are some interesting shipping ports in Europe that have gone almost completely automated. And just to give you an example, these vehicles are driving themselves completely. There's no human driver whatsoever. And you have something like 350 of them driving around at the same time, all going in different directions, all trying to take their particular cargo to the location that it needs to go. So it needs to have a lot of processing power by itself as well. It needs to be able to wirelessly communicate with the central hub to say, okay, I've got this particular container, what do you want me to do with it? So it can start to identify where it needs to go, plan its route, and then head in that direction. But it needs to know what it's got on there first. So you have some sort of camera, optical recognition, and it can read either barcodes or it can read the letters or the ID on there, or if there's like RFID sensors on there, then it can use those to sense what particular container that it has on there, and then it can be told what direction it needs to go. So from that point, it needs to know things like, okay, is there anything else in the area? Can I go here? Do I need to plan a different route? So let's take a slightly bigger picture here. There's a shipping port in Rotterdam in the Netherlands. So once the slides go out, I've got a Google Maps reference down there so you can actually go in and take a look for yourself as well. You'll notice that in the bottom image, there's a lot of very straight and curved lines and they look very well organised. There's actually, they've had coils that are embedded in the concrete there to create magnetic lines. So those particular robots, so you remember the line follow from earlier, where we had it with a light sensor. This is using the magnetic sensors to follow a particular line or a route, almost like having rails without needing them. And you can have the, what's the best way to say this? You can actually change the amount of magnetism in those lines to say how fast that robot is allowed to go, kind of like a speed limit. So you can think about how the robot can process all of that information on board. And once it gets the particular cargo container, it can then go on a particular path, it knows where it wants to go, and it can just follow a guided rail essentially all the way along. No human intervention needed whatsoever. So just to give you a rough idea, there's about 35 to 40 cranes that are automatically dropping the shipping containers onto these automated guided vehicles, and then they are driving off to the particular locations where they can then be picked up. And that's all happening pretty much 24 hours. So there's one of the largest ships in the world that's actually given in this particular National Geographic example, where it takes 24 hours pretty much to unload the ship, and they've got these robots working constantly to get the stacks to where they need to go. Okay, so I've got a limited amount of time left, so I'm just going to talk briefly about where does the industry go from here, and where do we look at students wanting to go, and how can we help them get there. So there's some very interesting projects which are coming up over the next few years. We've got the Sydney Metro, so that's a train line that's being built where the trains are completely driverless. Some people may have seen that, some people may have not, but I've got a link in there if you want to see more information. Google X, which is a smaller company of Google which has been renamed, is working on a self-driving car project. I know about 2 or 3 people that are going over there or have gone over there already, and they're working on different aspects like working with high-speed manoeuvres and some safety-critical features as well. Amazon Prime Air, so talking about drones, so they're working on drone delivery systems to, so if you think about the shipping ports that we had from before, you could have a warehouse that can then say, okay, this particular package needs to go to this address, and you've got drones that can actually pick it up and fly to that address as well. I know that Domino's Pizza was trialling that for a little while, but then they were worried about people starting to use nets to capture the drones, so they gave up on that idea pretty quickly. Tesla has cars that they're still provisioning for autopilot. They've got some autopilot features at the moment to drive out of a driveway, but they're working in small steps to build up to larger projects where you can be halfway across the country, say, okay, I want my car now, and it can drive from wherever it is all the way over to you. That's where they're working in the longer term anyway. And there's a lot of obstacle avoidance and programming and a lot of strange things that can happen that you need to take into account in the code. I've got a list of a few other things here, like say nanobots and micro-robotics or exoskeletons, people being held for either for military applications or for medical purposes, quadcopters, swarm robotics, anything else like that. I'm happy to cover any of those particular areas if people want me to go in a particular direction. You start off with small projects and then you can start to build on them a lot more. I remember there was one when I first started out. We had to write a small checkout system, which was like add an item, buy an item, sell it, then log into the back end and undo what everyone did. But that was very hacked together at the time. No security, no nothing like that. But then we built up from that and we added extra features in later on. So you can always manage those projects and extend them a lot more. So it's a lot of fun, I hope. It's kind of picture-based. So they'd have blocks or elements which you can put up on the screen. Think like if you've got, say like a Microsoft PowerPoint, like how I've got a flow chart here on this slide. I could have the first, so this particular one might be what would be called a line follow element or a turn element or a rotate, a motor element, and you can hook them up kind of like a flow chart. So it's what's like a graphical programming language rather than typing words. And then you can right click on those particular graphics, change some settings and say how long it needs to go for, what colours it's sensing, what other parameters that you want to put in there. You don't have to know the actual code, it's more of a put things together and then change the properties. So it's very approachable, but you're still learning a lot of the ideas behind having such things in education isn't, okay, we want our children to learn a programming language and it has to be Java, it has to be C++, or it has to be something like that. It's more about the programmatic way of thinking and the logic behind all of that. And so those Lego-based ones allow you to introduce those concepts without the steep learning curve of having to learn a programming language. Python is not one that I've seen used in the Lego or the Arduino side of things, but I've seen it used in one of the robotics tournaments that I'm involved with. There are some of the students there that have actually used Python to control their robots that are upwards of around 40 to 50 kilos. And they actually ported it over so they could use Python themselves. So the only options were really either Java, C++, or another graphical programming language called LabVIEW. And they did some tricks behind the scenes on the hardware to allow them to run their compiled Python scripts instead, which was very interesting, and a lot of us were wondering how on earth they did it, so we had a very interesting interview session with them afterwards just to see how they managed to do it. So by all means, go exploring, go tinkering, and just make sure things don't break, I guess is the one thing. So there was one, okay, so I'll just go back a few slides. There was one particular link that I had here, which is www.arduino.cc. And they have a lot of links to community forums, ideas, projects, and things on there. Intel have what's called their Edison platform. I can provide links with the slides later if you want me to as well. So Edison is Intel's expansion based on Arduino, where you can have some extra things running on there as well. So that's another area where if you want to expand further, then you can certainly do that. But mainly, if I've been looking for anything, I've just been going through that one website and then searching through the recommendations through the forums there. Strangely enough, the biggest barriers to this are not the technology, it's the regulation. If you think about no one's driving the car, who is at fault if it crashes? Who pays for the damage? So there's those questions that are going through a lot of the political scenes at the moment, and there are different answers around the world, so it gets to be very interesting there. Metropolitan environments, so sealed roads, are at least a bit more manageable, but to get autonomous vehicles onto dirt roads and tracks might be a bit harder, and that presents other challenges as well. So depending on the environment, it might be that it takes a while longer for autonomous vehicles to be used. And generally where there's large population and demand for the autonomous vehicles, it might be that you can use them as transport hubs, and then you have locally drive vehicles around from there, rather than having the autonomous vehicles all the way through. So there are a few examples. There's one that I know of where there's an issue in the Great Barrier Reef with a number of crown-of-thorns starfish. And what they're doing is they're using autonomous robots to actually swim through the water, be able to use image detection to find these ones and then inject them with the salt solution, which stops them replicating and they die off after a day or so. A lot of that at the moment is humans just swimming around and trying to do that, but then when the crown of thorns come out mainly at night, it's harder to see them. So to have the autonomous vehicles there, that's a pretty interesting project. That's in its final phases of testing at the moment, I think. There's different levels of landing. So I know that SpaceX has their own rocket program at the moment with rockets that launch and then land back on the ground, and a lot of that is automated as well. One other project that I found interesting was to do with swarm robotics, so a lot of smaller copters that are flying around that can start to communicate with each other. And they're being used in areas where it's like, say, fire zones or something else to try and see if there are any humans or animals or anything else in particular fire areas. Also in disaster zones in buildings. A lot of those are autonomous robots where you're doing a bit of a search and find and rescue thing. There's also a competition up in Queensland that runs every 2 years, I think, which is an autonomous search and rescue type project. I don't have the details there, but I can get the details and put them up with the slides on the website.
Thank you.
Thank you very much.